This video is to summarize the 10-minute summary of Investigation 3D. So we've learned three important things in this investigation, direct and inverse variations, and also 6 basic graphs and how to translate those basic graphs. So the first point is the direct and inverse variation. So the direct variation is if one number is going up, like that, and the other number is going up too. So that it's going up. And if you plot each point as a coordinate pair, in other words, if you plot 0, 0 for this, or 1, 3 here, with, if you graph it, you'll see something like that. And inverse variation is, on the other hand, if one number is going up, see the x value is going up, y value is actually going down. It's getting smaller and smaller. And when x is 0, it's undefined because you can't divide any number by 0. And the graph will look like this. Okay? So that's the direct and inverse variation. 6 basic graphs. So the first one is the direct variation. The equation is y equals c times x. That c is the constant, so you can put any number you want. So another example of those will be y equals 2x, or y equals negative 3 over 2x, or something like that. Or it can be even y times, as long as it's the real number, you can do square root of 2 times x. Don't get confused with that equation as with square root of 2 times x. This is a square root function. This is not direct variation. Inverse variation is y equals c over x. So it can be y equals 2 over x, or y equals square root of 2 over x. As long as the number is real number, you can put anything you want. Again, or you can even do y equals negative number, negative 3 over 4 over x, things like that. The third one is the quadratic growth, which is y equals x squared. When x is 1, then you have y equals x times x squared, so you can put 1 here and y equals 1, and the graph will look like this big smile mark. The cubic growth is y equals x to the third power. You see, this one has second power on top of it, and this one has third power on top of it, and we say cube. The graph will look like some kind of water slide function, maybe something like that. You've seen that in water country or somewhere, something like that. How does the equation work? You can plug in whatever x you want. So we have y equals whatever the number x to the third power, and if you plug in, for example, it's 2, then y will be 2 to the third power, which is 8. So the coordinate will be x equals 2 and y equals 8. Fifth equation is a square root. So we have y equals square root of x. And the graph will look like half of quadratic. You see, if you compare that line, that curve, and this curve right there, you'll see what I'm talking about. Hello? Who's this? Okay. Hello? No, that's okay. This video is 10 minutes summary of investigation 3D. So the first key point we went through in this investigation was direct and inverse variation, and um, so let me explain what the direct variation is. So the direction variation means when one value goes up, the other number goes up at the same rate, as you see. And if you graph it, the number will be straight going up. The inverse variation is if one number is going up, you see this number is going up, x value is going up, the y value is actually going down on the same rate. And graph will look like this. And very importantly, and when x is 0, it's undefined because uh, this line is going closer and closer to x, but it never touched. So when x is 0, there's no value. So it's not defined. Point 2, 6 basic graphs. So the direct variation is the first graph, and this is a very simple linear equation of the basic graph. You plot the points. When x is 0, it's 0, y is 0, and this c could be any number, you know. So it could be y equals 2x, you've seen that before, or it could be negative number, or it could be fraction, for example 3 over 4x, or even it can be square root if you want, like square root of 3 times x. You know, don't get confused with y equals square root of 3x. This is actually a square root function, so it's a different things. So forget about that right now, for now. And the second graph is the inverse variation that we just did, and graph will look like that. And when x is 0, it's undefined. Uh, and the third one is the quadratic growth. The uh, graph will look like a big smiley mark like that, and you can plug in whatever number for x you want. So for example, if you plug in y equals some number to the second power, for example 3, then that will be 3 to the second power, which is 9. So when x is 3, y will be 9 up there. The fourth one is cubic growth. So the difference between quadratic growth and cubic growth is the exponent right there. The graph will look like some kind of water slide, really scary one, scary water slide maybe. And yeah, so y equals, if x is 2, then that will be 2 to the third power, which is 2 times 2 times 2, which is 8. So the point will be 2 and 8. Fifth one is the square root. Square root graph will look like half of the cube quadratic curve. If you compare that, the curve of this part, doing a horrible job right now. The curve of this one, right there, well, I give up. Will look like that. Well, in other words, if I draw another one that's symmetrical, it'll look like a quadratic growth, and if you rotate it 90 degrees, it'll look like a cubic quadratic graph. Also, value graph looks like a V, like that, and if you plug in some numbers, y equals also value of -2, that will be 2. So if x is -2, y will be 2. And finally, translation. So this is the basic graph, and then this is the translation graph. So the translation is, if you add to some number to y, then the graph will shift to the left, and if you add some number to x, then the graph will shift shifts to, oh, wait a minute. If you add to y, then the graph will shift to upwards, no, downwards, I'm sorry. And then if you add to x, the graph will shift to the left. And if you subtract it, opposite will happen. So we have, let's say, this is a rough sketch of y equals x squared. And then we are adding 2 here, so the graph will shift down 2 spaces. And then also we are subtracting 6 from x, so the graph, the vertex will shift 6 spaces to the right. 1, 2, 3, 4, 5, 6. So that will be here, and the graph will look something like this. The shape will be the same, but the position will be different. And that's the summary of Investigation 3D.